Hi all, my name is Brenda Crespo Perez and this is my Teach 1 presentation on risk-adjusted P-charts. This presentation was prepared as part of the HAP 725 course taught by Dr. Farouk Alemi at George Mason University. As an overview of the topic of my presentation, we can note that risk-adjusted P-charts allow decision makers to compare observed and expected outcomes. So essentially, we are analyzing outcome data over time and identifying patterns. It is important to always check for assumptions when analyzing risks. Adjusted P-charts. So some examples of assumptions are shown there on the screen. In this presentation, I will be going through how to solve comparison of rates, question number 3, which is shown on the screen. And the provided data is also shown there. We will be using the outcome data to identify whether the facility is having more infections than expected from the patient's conditions. The analysis steps for this question is as follows. We will be going through cleaning the provided data and calculating rates and values, and finally we will plot the risk-adjusted P-chart. Starting off with step 1, we will be importing a few libraries as shown and reading the data into a Jupyter Python notebook. Once that is done, you want to check your column data types to confirm they are marked as float, in which they are shown over here. Finally, we're going to rename the columns as risk P1, risk P2, and so on. Your final table should look like the picture here on the bottom right under out. Note that all the codes throughout this presentation will be presented on the left under in, and output will be shown on the right under out. Step 2 will be calculating observed infection rate. The first step here is to calculate the number of cases per week, or essentially per row. This number is shown under column N. Then we will utilize number of cases to calculate observed infection rates. The calculated rates are shown under observation rate column. In step 3, we will calculate the expected infection rate, which equals the average of each week. The rates can be found under expected rate in the table as shown here. Step 4, we will be calculating expected deviation. First, we have to remove all nulls from the table. I found there to be about 7, and then I replaced them with 0 to calculate the expected deviation. And those can be noted here in yellow. They were all changed to 0. The expected deviation calculation is shown in the left column, and values will be shown in the bottom right table under the expected deviation here. Step 5, we will identify t-values. So to identify t-values, we need to first calculate degrees of freedom, which equals number of cases minus 1. Once the degrees of freedom are calculated, we will look them up using a t-table, which is available via a Google search. So please note that we are using alpha of 0.05 and that you should be looking at t-values under two-tailed t-distribution table. And you can see the table here below, and I took the values here for those with degrees of freedom of 2, 3, and 5. And all of that is inputted into these two columns here of DOF and t-value. So in step 6, we'll be calculating control limits in preparation for the final plotting of the risk-adjusted P-chart. So the upper control limit is calculated by adding expected rate to the result of t-value times expected deviation, while the lower control limit is calculated by subtracting expected rate to the result of t-value times expected deviation. So after doing so, your table should look like the top right table with two new columns, noted as UCL and LCL. We will need to replace limits because essentially negative limits are impossible in probability, and also probability you can't really have anything higher than 1. So this step is done in the second part of step 6 as shown. So your table should come out looking like this bottom table here. So you see how these two columns were essentially altered. So now that you have all values prepped, you can plot your risk-adjusted p-chart to answer the question. Always make sure that you are labeling your table correctly and highlighting your control limits in red. So you have your X and Y labels and you have your legend and title. So the final adjusted p-chart for question 3 is shown on screen. Essentially, we can note that the observations are within the upper and lower control limits. So therefore, we know that the facility is not having more infections than expected from the patient's conditions. So I hope this presentation was helpful. Please let me know if you have any questions or concerns. But thank you for watching.